we are still looking at integration, and we have developed the concept that it's a reverse of differentiation. So let's look at what's called integral notation. Integral notation, which you have always seen this symbol here. Okay? Now, we are aware that if I say dy by the x is equal to 2x at the derivative, and this derivative comes from the function y is equal to x squared plus c. That's what we've agreed, that should you differentiate any, integrate any function, you must only put a constant. We call constant of integration, which is an arbitrary constant, right? Now, that therefore means I will say the integral of 2x dx is equal to x squared plus c. Now, what does this one mean? So instead of using the word integrate, this symbol here tells us the meaning of the word integral sign. This we call it integral sign. What about this one here? This part here means we are integrating with respect to x. That's what it means. So the x means I'm integrating this function with respect to x. That is what it means by this. Where this symbol here stands for the integral sign. So therefore, if I ask you to find, if I say find 2x dx, I'm saying you integrate 2x with respect to x. That's what I mean by that. So that is what we call the integral notation, which we shall be using at all times, the symbol this, right? Now let's look at an example. For example, now if I can also give you another one, I say maybe find the integral of 3x dx. What does this one mean? It means I'm integrating 3x with respect to x to give me the answer, which we shall look at how to handle them. Now, let's look at the general results. General results of how to integrate. Okay? If I have a function y, maybe y is equals to or dy dx is equals to a x to power n. Let's say this function I have this like this, or derivative. This is derivative. How do I now find the function y? The general rule says y alone as the function would be given by a x to power n plus 1 all over n plus 1 plus c. That is the general rule of integration. What am I doing? I'm adding 1 to the power, that the power of x. Remember, this a is a constant, which may not be affected by this. The integration is in respect to x, so it is x is my constant. Therefore, I will now add 1 to the power of x, which is now n, and get a new power, which is n plus 1. After that, I divide by the new power, which is n plus 1. So this becomes my general rule of integration. But of course, remember to put the constant c after doing the integration. Now, as I told you earlier on, I said if this is the derivative of this function, I can find the function. That's the reverse of differentiation, which I now call integration. Therefore, the function y is given by this. This becomes my general rule of integration. Now, can we prove it back? How do we move back from here up to here? It's just true. Now, if I want to prove it, I will say, if my y is now x n plus 1 over n plus 1 plus c as the function. Can I go back here? I want to prove it. How do I prove this? So I can say dy by dx by simple method of differentiation. What happened? I fold this power down, so up n plus 1. Of course, this a is here. Then x to the power n plus 1, of course, minus 1. Remember, I'm differentiating, I reduce 1 to the power. Of course, this part remains here, n plus 1. Now, the moment I differentiate the constant, it goes to 0. Therefore, my dy dx give me now, you see, this term is appearing here, this term is appearing here. And they can reduce to remain now a x to the power n plus 1 minus 1. Plus 1 minus 1. Which of course 1 will go to 0. So I remember dy by dx to become a x to the power n. Which gives me back this function. So it means the integral of this function is this. So what does the rule say? When I'm given a function to integrate, I add 1 to the power. After adding 1 to the power, I divide the new power. Of course, I put the constant c. That's how the general rule for integration. Let's look at the example. How to apply the example.